Okay, so we're back to solving systems of equations again. We did that back in chapter 5. So, but the types of systems of equations we're going to solve in this lesson are called non-linear systems. So let's review first of all what a system of equations is. A system of equations is two or more equations working together. So in other words, when you solve them, the solution or the solutions have to make every equation in that system true. So a system of equations is two or more. Good news is we're going to just work with two equations working together. If you remember right, in our system of linear equations, how did we find our solutions? What were they represented by? Let's think of the first way we learned to solve systems of linear equations. We solved by graphing. What were we looking for on the graph? Ooh, that was so long ago. Not the y-intercept. Not the x-intercept. So we got this, okay, let's go back to chapter 5. We got a line, we got another line on the graph. The point of intersection. We were looking for what points do they have in common? What points do they share? So we are going to say the points of points of intersection. Okay? Now when we have a nonlinear system, when we have a linear system, we either had no point of intersection, one point of intersection, or an infinite number of points of intersection. Remember when the line was on top of the other line, we called that an infinite number? Okay, so in this case, when we are talking about our nonlinear systems, there can be 2 points of intersection, there can be 1 point, or none. We will not have an infinite number. Instead, what should turn out is you should either get 2 points of intersection, 1 point of intersection, or none at all because they do not intersect. Okay? So nonlinear does not mean none of them are linear. It just means that not all the equations are linear. So nonlinear just means not all of the equations are linear. So we can have a linear equation in a system, but then one or more of the others needs to be nonlinear. Okay? So we're actually going to do 2 of them, and we're going to use the graphing calculators to verify what we get and to see what's really actually happening. So we're going to do it algebraically first, okay? So we have y equals x squared minus 2x minus 5. Tell me what type of a function is that one? You know, lately in all my classes, I feel like I'm the only one showing up. Thank you very much. It's a quadratic function. Okay. So what kind of a graph should that give us? A parabola. What would this parabola do? Open up or open down? We should have a parabola opening up. Okay, so we already have a start to a visual of what's happening here. Our other equation in our system, y equals 2x minus 8, what type of function is that one? That one's linear because it's x, the degree of the 2x minus 8 is just 1. Remember, degree 1 is linear. So now we also have a line on our graph. So we are looking to see, does this parabola and this line, by the way, what would this line be doing? Rising or falling from left to right? Rising, because what?
B is positive.
Not because B is positive, but remember B is the y-intercept. The slope, M, is positive. What is the slope in y equals 2x minus 8? 2, yeah. What's the B, Doc? Negative 8, and that's our what?
C.
Well, it's kind of like our C in our quadratic equation is our y-intercept, isn't it? In a linear function, B is actually the y-intercept. So we have this line that is rising from left to right. We have this parabola that is opening up. We are looking for, is there any points of intersection? Does this line ever touch or cross through this parabola, basically? or vice versa? Does this parabola ever cut through this line or touch this line anywhere? So we're going to use, when you look at your lesson in the book, they use a variety of ways. We are going to use the substitution method because I think that is the one that will help you be most successful. Anybody remember the substitution method? Tucker?
Since like the bottom one or either one are equal to y, you can substitute whichever one you want for y.
Yeah. So since both of them are set equal to y, we can take one of them and say, you know what? The expression on the other side that is set equal to y, that can replace the y in the other equation. So circle those. And that's what we're going to do. We are going to put this expression into the other equation for y. So we are going to have x squared minus 2x minus 5 equals 2x minus 8. We could have done it, we could have also, we had this option. We could have done this. We could have put this into this one for y. It wouldn't have mattered. Either way, we're going to have 2x minus 8 on one side of our equation and the x squared minus 2x minus 5 on the other. Okay, so what we're doing is we are, let's put right here, we are solving, it's already there. We are solving it by substitution. So now our next goal is going to be get set equal, write this in your notes so you have it, get set equal to 0. In other words, get all of the terms on one side and there should be a 0 on the other. So what could we do? What would be a good place to start?
Add 8.
Add 8, okay,
Sides.
to both sides. Okay, so we have x squared minus 2x plus 3 equal to just 2x on the other side. Next move, subtract 2x. Because again, we want this to be set equal to 0, so we might as well line it up under the like term on the other side. And we now have x squared, what?
Minus 4x.
Minus 4x plus 3 equals 0. Look at there, we have a quadratic equation to solve now. Okay. So we are going to solve for x. We're going to solve that equation for x. Suggestions. We know some ways, right? The diamond method. In other words, you're thinking maybe we could possibly solve this by factoring. Okay, let's get our a, b, and c identified then. A equals,
1,
b equals,
negative 4,
c equals.
3.
Okay. Well, let's try the diamond method. If the diamond method doesn't work, can we just stop and say, oh, it's not solvable? No, what did we learn yesterday? You have to always at least try the quadratic formula. Remember, the quadratic formula works for any quadratic function. If it doesn't work, if you can't get it to work solved by the quadratic function, then it's not solvable. But it is, you at least have to try that. So a is 1, so we don't need to multiply by a. We can just put our c value up there, our b value down here. What are the numbers? Negative 3, negative 1. Okay, what can we do with that negative 3 and that negative 1? A is 1. Don't work very hard.
X minus 3.
minus
X minus 1.
Yeah, we can rename, we can say the factored name. We can go straight to the factored name because a is 1. So we have just renamed our x squared minus 4x plus 3 as x minus 3 times x minus 1. Remember, we're solving for x, so what do we have to do?
X minus 3 equals 0.
X minus 3 equals 0.
X minus 1.
X minus 1 equals 0. We have 2 solutions for x. So what's our x value here?
3.
3. X equals 3. What's our x value here? 1. Okay. So these, we just solved our quadratic. But what do we need? We need points of intersection. So what's missing? We need the y
We
value,
need
right?
to substitute.
Oh, so we can substitute, we need to find our y's. So does it matter which of those two equations in the beginning we use?
No.
Well, which one do you want to use?
2x minus 8.
Me too, I want to use the linear one. So we are going to, let's put here, now find y. And you can use either of the equations. You guys made a good choice. Use the linear one. So, let's do it for when x equals 3. Let's start with that one. So y equals 2 times 3, take away 8. 2 times 3 is 6, take away 8. Our y value is -2. Oh, there's a y value to go with our x value of 3. We have ordered pair 3, -2. Okay, there's one of our solutions. And now we will do it when x equals 1. So we'll sub 1 in for our x and evaluate the expression on the right side. And what do we get? Y equals -6, which then means we have a y value of -6 with an x value of 1. So 1, -6 is also a solution. Okay, now we're going to use our graphing calculator, so we're going to verify it. This tells us right here that that line is crossing through the parabola in how many locations? 2. And specifically at those locations, right? So I want you to go to y equals, clear out anything that's in there. And we're going to put our quadratic in first. X squared minus 2x minus 5. X squared minus 2x minus 5. And then in y sub 2, put in our linear, 2x minus 8. Do a zoom 6 to get a nice graph. Do we have our parabola opening up? Do we have a line rising from left to right? Are they intersecting in 2 locations? Yes. Okay. What should happen in the table then if we have the right solutions?
X is 3, which is -2.
Okay, so let's go to the table. Second graph takes you to the table. We'll find x equals 3 in the table. You should have an x column, you should have a y sub 1 column, you should have a y sub 2 column. When x is 3, they are both sharing a point. And that y value should be -2. Are the both y values -2?
Yes.
Okay. Go to where x is equal to 1 then. Are both the y values -6? Okay. Then we're good. We did it. Questions? Okay, let's go try one more on the back side. Turn your calculators off in the meantime. Okay. So here we are again. We have the system of nonlinear equations because one of them is not linear. It is quadratic, isn't it? So tell me something about this line. Y equals x minus 5. Should that be a line rising or falling from left to right? Rising from left to right. Let's just have a little sketch there. What should be going on with that second equation?
Parabola opening up.
A parabola opening up we should have, okay. So, somebody tell me, we just saw a picture of where there's 2 solutions. Tell me when would there ever only be one? When you have a parabola and a line. When it touches the vertex. Remember the only point that does not have a reflection point? So if the line is intersecting the vertex of the parabola, we would only have one solution, wouldn't we? When would we have none? Misses it completely. They're not, they're paying any attention to each other. They're never going to meet up. Okay, well, let's go about solving this algebraically, because that's what we're doing today. Okay, what are we gonna do? Substitute, okay. And even though it may be in the directions of the homework, it might tell you to solve it by a different method, just stick with substitution method, because that's what we know really well, okay? So we're gonna put x minus 5 into the other equation for y, right? Or we could put x squared plus 2x minus 3 into the top equation for y. Doesn't matter, because they're both set equal to y. So we are going to have x minus 5 equal to x squared plus 2x minus 3. So in other words, we are solving by substitution. That's a fancy B. Solve by substitution. Okay, would you get that set equal to 0? You know how to do that. So would you get that first of all set equal to 0? You remember what I said though, you know, don't be so inclined to want to make sure that the 0 is on one side or the other. Doesn't matter which side 0 is on. What do we want the A value to be whenever possible? Positive, and we want it to be a positive 1 especially, right? If we can. Okay, so make sure when you're rearranging this to think of that you might want again, we have a quadratic, so we are going to solve for x. A equals, B equals, C equals. Want to try factoring it? Let's just do a little diamond here quick and check it out. We'd have to have something that multiplies to be 2 and adds up to 1. Is that possible? Okay, well then we got to, so we're going to say not factorable, but hear me on this. Just because it is not factorable does not make it no solution, not solvable. No, what does it mean we have to try now? Now we have to try the quadratic formula. So now we say, okay, well, we got our A, B, and C. We need to substitute into our, let's just write the quadratic formula again because we want to keep this in our memory. So you did 12 problems over today. So you can go ahead and get this one subbed in and see what happens. Start doing your work. Remember, substitutions go in parentheses. You should have 5 sets of parentheses when you are done subbing in. Oh, we have a negative discriminant. When we have a negative discriminant, we can't take, you know what, we better put that bold and loudly in our notes. Can't take the square root of a negative number. I don't care what the number is, as long, if it's negative, you cannot take the square root of it. Now, we get to say what?
Solution.
No solution. Not because it wasn't factorable, but because the tell-all quadratic formula says, oh, wait a minute, you end up with a negative discriminant, that -7 right there, and that's a problem. So we are going to say that there is no solution to this system. If we can't find x values, there's no way to find y values for the ordered pairs. Let's go see what the calculator shows. What do we expect should happen on the calculator? Parabola opening up, a line rising from left to right, that what? Don't touch, see if it's true. Go to y equals and put in both equations. I want you to see this. I want you to have a visual of it. Why we were not able to solve this algebraically. So x minus 5 goes in one of them, x squared plus 2x minus 3 in the other. Press graph. And are we ready? Is there any possibility that ever, what if we expanded the graph made bigger? Would they ever meet? No. No solution. They have to intersect because they're working together as a system, right? Okay. Questions? Do not shortcut your work. You only have 4 problems to do, and I expect you to get all 4 of them right. Because you're spending enough time with them, showing enough work, and getting good answers, okay? So, if you don't have any questions, you can go to work on those 4 problems you have for homework.